So I actually explained number 1 on a previous video, okay? So you graph that exactly the same. You use the inputs that are in order, -3, -2, -1, 0, 1, 2, 3. You plug in the easiest one, 0, right in there. So what's 3 to the 0? That's 1. Anything to the 0 power is 1. And of course you have a negative in front. So when you plug in a 0, you get out a -1. And now after that, you could simply focus in on your growth factor, which is the base. And the base is 3. So to get from -1 to the next output, all you have to do is take that -1 and multiply it by 3. So what's the next output going to be? Multiplying by 3. It'll be -3. And what's the next one going to be if you multiply by 3? It's going to be -9. And then the next one, -27, which is already off the graph. You don't need to do that. Now, if you're multiplying by 3 this way, the opposite way would be dividing by 3. Does that make sense? So if you're at -1 and you divide by 3, what would you get? You get -1/3, -1/3. And then if you divide by 3 again, you'd get -1/9. And you divide by 3 again, you'd get -1/27. Yeah, but if you know how to multiply by 3 or divide by 3, you don't need to do anything with the calculator. So let's look at the coordinates here. The coordinate 0, -1 is right here. Let's go to the coordinate 1, -3. It's right there. If we go to 2 and -9, it's down here, almost off the graph. I'm going to stop right there. And then going into the negative directions, -1, -1/3, that'd be right there. And then -2, -1/9, that's even closer to 0, closer to 0. We're actually going to draw it like if it's actually touching the x-axis. But we know it never actually touches, it just infinitely approaches. So we do have this exponential growth function. And do I need to shift it up or down? No. Why not? Because there is no k value, and that's it. If you want a more detailed explanation on this question, please look at the previous video on question number 1. Let's take a look at number 2. Again, we're going to make a XY table, and we're going to put consecutive integer inputs from -3 to +3. And after that, all we have to do is plug in one simple number. The easiest number to plug in is what?
0.
0. So when you plug in 0 right there, it's going to be 3 to the 0. And what's 3 to the 0?
1.
It's 1. And how about 1 times 1/3? 1 times 1/3 is 1/3. So when you plug in 0, you get out a 1/3. Okay? Now you could, if you wanted to, plug in a 1 right here and say 3 to the 1 is 3, and then 3 times 1/3 is 1. So you could do all that math, but the easier thing to do is to recognize that the growth factor is 3. The growth factor is 3, so to get from one output to the next output, all you have to do is multiply by 3. So when you go 1/3 times 3, you actually get 1. And then the next one would be multiplying by 3, which would be 3. And then the next one, multiplied by 3, you get 9. Does that make sense? Yeah. Going backwards, instead of multiplying by 3, you could divide by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. What's 1/3 divided by 3? It's 1 over 27. I mean, 1 over 9, I'm sorry. And then the next one would be 1 over 27. And at that point, you already know it's super small. You don't need to do anything else because it keeps getting closer and closer to 0. So let's graph what we have. Let's graph 0, 1/3 in red. 0, 1/3 of the way up would be down here. It's not even halfway up. Then if I go to 1, 1, it's right here. If I go to 2, 3, so means I'm going to go 2 on the x, 1, 2, 3. And then 3, 9. 3 and 9, it's way up here almost off the graph. Now let's take a look in the negative direction, -1 and +1/9. So if you're at the origin and you go -1 and +1/9, you hardly go up at all. So -1 and +1/9 is right there. And then -2 and +1 over 27 is right there. It looks like it's touching. Even though we know it never actually touches, just infinitely approaches. So we draw the growth function. And do we need to shift it up or down? Do we need to shift it up or down?
No.
No, because there's no k value. Okay, it doesn't say plus 5 at the end of it all. It's just y equals a times b to the x. Let's move on to number 3. Are we going to have to shift on this guy?
Yeah.
Yes, because there's a plus 5 at the end of it all. So once again, let's start with the xy table. Let's plug in some consecutive integer inputs from -3 to +3. And then let's take our time and plug in 0. Now, check this out, guys. You could plug in 0 right there and then say 2 times 0 is, 2 to the 0 power is 1, and then 1 times -1/2 is -1/2, and then take that -1/2 and add 5 to it, and that would actually be 4.5. And you get decimals and fractions, so it does get kind of ugly. This is why whenever we have a k value or even an h value, we ignore the h and k. I like to box in the function without the k value. And I'm going to create the coordinates to this boxed in function that we call the parent graph. And then after I get the coordinates and after I graph it, my final step would be to incorporate the k value, which would be to add 5 to it. Does that make sense? So let's come up with the coordinates to what we have inside the red box. When we plug in 0 right there, 2 to the 0 is 1, and then 1 times -1/2, that is -1/2. So when I plug in 0, I get out a -1/2. Now, if you want, you could plug in a 1, and 2 to the 1 is 2, and then 2 times -1/2, that's -1. Or you could simply recognize that the growth factor is 2, so you're going to just simply multiply the -1/2 times 2, and that'll get you to the next output. So what's -1/2 times 2? That would actually get you the -1. -1/2 times 2 is -1. And then from the -1 to get to the next output, what do I get? When I multiply by 2, I will get -2. And then to get to the next one, what would I get? -4. And then to the next one, what would I get? -8. Multiplying by 2. Now, I'm just going to add on a 4 down there, since the y value of -8 will be able to show up on this graph. Now, if I'm multiplying by the growth factor going down, multiply by 2, multiply by 2, multiply by 2, backwards would be dividing by 2, dividing by 2, dividing by 2. 1 divided by 2 is half. -1/2 divided by 2 is what? -1/4. -1/4 divided by 2 is -1/8. -1/8 divided by 2 is -1/16, and so on and so on. But at that point, we already know it's so small, we're not even going to be able to draw the difference. So let's actually graph all of these coordinates starting with 0 and -1/2. 0, -1/2, that would be right here. And then, let me do it in red. And then 1, -1 is going to be right here. And then 2, -2 is going to be right here. And then 4, -8 is going to be over here. No, I'm sorry. 4, -8 is way down here. Wait, I skipped one, huh? 3, -4 is what I should have said. I'm sorry. 3, -4 is right here. And then 4, -8 is down here. And going in the negative direction, -1, -1/4 is right there. -2, -1/8. And it keeps getting closer and closer to 0. So we're going to draw it like if it's actually on it, but even though we know it never actually touches, just infinitely approaches. So this is the parent graph. This is what's boxed in red. Now, if I want my actual complete graph, I need to take into consideration the k value of +5. So I'm going to shift this whole graph where? Up 5 units. So you guys see the asymptote right here that used to be the asymptote y equals 0? Now it's going to be the asymptote y equals 5. 1, 2, 3, 4, 5. So here's my new graph in blue. And I need to take every single one of these points, like this coordinate right here, I need to move it up 5 units. 1, 2, 3, 4, 5, and put a dot right there. Now I'm going to do it in blue so we can see the difference. And I need to take this next one and move it up 5 units. 1, 2, 3, 4, 5, and put a dot right there. And the next one, move it up 5 units, and it'll be right there. The next one, move it up 5 units, it'll be right there. Next one, move it up 5 units, it'll be right there at that halfway point. And then it gets closer and closer and closer to the asymptote that we have over there. So our graph, including the k value of plus 5, is this blue graph. It's an exponential growth function going in a negative direction. So this red one, it does not count. That's why I'm putting X's on it. The blue one is the one that truly matters. So now that we have that blue one, let's state all the important information. Let's talk about the domain. The domain of any exponential growth function is what? All real numbers. Everybody should know that. Now the range, this whole blue graph is below a certain level on y. What is the asymptote? Here's the asymptote. Right? That is the y value of 5. That is the asymptote. I'll abbreviate it, asym. Okay, so if my blue graph is all below the value of 5, how could we state that in terms of an inequality with y? It would be what? The range is, y is it greater than? If it's below? Less than what? Less than 5. So the range is y is less than 5 because the asymptote is 5. So it never actually touches 5, it's below 5. And that's about it, unless we ask for the y-intercept. That would be the coordinate y-int. Do not say it's this guy, because that's the y-intercept of the parent graph. Okay, if you want the y-intercept of the blue graph, of your actual graph, you actually have to add 5 to the output. So where is this location on the y-axis? Here's the 0, 1, 2, 3, 4, and then halfway up. So 4.5. So 0, 4.5, 4.5. That would be your y-intercept of that blue exponential growth function. Let's take a look at number 4. So number 4 over here, let's set up a table. What kind of inputs do I want? Any inputs I want? Can I plug in a 2, a 5, a 7? No, you want to be organized. Consecutive integer inputs. So let's do the order -3, -2, -1, 0, 1, 2, 3. And again, I'm going to ignore my k value. I'm going to focus in on what's inside the red box. I'm going to graph that, and then I'm going to shift it 8 units where? Down, that's right. So if I plug in 0, into the x, it's going to say 2 to the 0. What's 2 to the 0?
2, no, 1.
1, and then 1 times the 2 in the front. What's 1 times 2? That is 2. Ladies and gentlemen, that's your first coordinate of your parent graph, not the actual graph. This is the first coordinate of your parent graph. So we have 0, 2, 0 on the x, 2 on the y. It's right there. And now I could, if I wanted to, plug in the number 1 and then work out the math, plug in the number 2, then work out the math, plug in the number 3 and work out the math. But the easier thing to do is to recognize that you have a growth factor of what? How does this grow? You got to look at your base. The base is 2, so it's growing by 2. So if I have this output of 2 and it grows by 2, what would the next number be? 4, because 2 times 2 is 4. That's right. And what would the next number be? 8, because 4 times 2 is 8. And the next one? 16, because 8 times 2 is 16. It's growing by 2. Remember, the base 2 is a growth factor, and you're multiplying. So if you go 2 times 2, you get 4, times 2, you get 8, times 2, you get 16. Going backwards, it would be dividing by 2. So this next one up here would be what? What is 2 divided by 2? Yeah, half of it is 1. And then half of 1 is 1/2. And then half of half is 1/4, and so on and so on. It keeps getting smaller. So this is the parent graph. It's not the final graph. So if we graph the coordinate 0, 2, we already did that. If we graph the coordinate 1, 4, 1, 1, 2, 3, 4, it's right here. Graph the coordinate 2, 8, you're almost off the graph. The coordinate 3, 16 is off the graph, so I'm not even going to graph it. let me graph the negative ones. So negative 1 and 1, whoops. Negative 1 and 1, negative 1 on the x, positive 1 on the y, there it is. And then negative 2 and 1/2, that would be right there. Negative 3 and 1/4. And the next one would be negative 4 and 1/8, and then 1/16, and so on and so on. And it infinitely approaches the x-axis. Now remember, this is your parent graph, not your final graph. So I wouldn't even draw a line through it, but if you want to, go ahead. But at the end of it all, you need to put 2 x's on it, because that's not your real graph. Where's your real graph? You have to shift all of these blue dots down 8 units. So let's start by the asymptote. Take that asymptote, which was at y equals 0, and now let's move it down 8 units. So you're going to end up with your new graph infinitely approaching -8 if you're going from right to left. Does that make sense? I simply took this arrow that was on the or the y equals 0, I moved it down to y equals -8. That's my asymptote. And I need to take every single one of these other coordinates and move it down 1, 2, 3, 4, 5, 6, 7, 8, and put it right there. And then I need to move this other one down 8, 1, 2, 3, 4, 5, 6, 7, 8, and put a dot right there. And then we're going to move the other one 8 units down. So this one, 8 units down, is going to be down here. And the next one, 8 units down, will be right there. And then half of that's right there, and there, and there. And it keeps going, approaching that asymptote. So the red line is your actual exponential growth function. Now, again, the asymptote, I've been drawing it as a green line all the time. It should be dotted, I guess, because it's not an actual line that you draw. But the asymptote is y equals what? What's the asymptote? Y equals -8. Okay, so we still need to talk about domain and range. The domain of the red line. What's the domain? Seriously, guys, if you get this wrong, that's ridiculous. X is all real numbers. It's always x equals all real numbers for domain. Cannot get that wrong. It's always the same answer when I ask you for domain. X equals all real numbers. How about the range of that red line? We're talking about y's, and all the y values of this red line is above a certain value. What is that certain value? It's above what? It's above what? It's above -8. So how do you represent y is above -8 in terms of inequalities? Y is above. What does that mean? Y is above, greater than -8. Now, if you wanted to state the y-intercept, the y-int, that's going to be the coordinate. Now, normally we would say this is the y-intercept, but that's from the old graph. This is from the parent graph. We don't actually use these. You want the actual y-intercept of the new graph in red. So you need to focus in on this coordinate right here. Or you could take this one and simply add the k value of -8. So what's 2 plus -8? -6. And as you can see, it does cross at -6. So the y-intercept value is 0, -6. And that's all there is to state about that question on number 4. You do an XY table, and what inputs are you going to use? Now, let's actually plug this in, but remember, we're going to do the parent graph. We're going to ignore the k value, just box in that part right there. And let's plug in 0 right in here. 4 to the 0 is 1, and then 1 times -1/2, that is -1/2. So instead of plugging in 1 and working it out, or plugging in 2 and working it out, or plugging in 3 and working it out, I'm simply going to look at the growth factor. What's the growth factor here, Andrea?
4.
The growth factor is 4, which means if I want the next output, all I need to do is multiply it by 4, and I'll get the next output. So what is -1/2 times 4? Or what is -1/2 of 4? -2. And how about to get to the next one? I'm going to multiply it by 4 again. So what's the next one? -8. We're multiplying by 4, right? What would the next one be? negative 32. Because 8 times 4 is 32. Right? Okay, you guys need to know that the growth factor is multiplying by 4. Backwards would be dividing by 4. So over to the next one, up B, if I were to take 1/2 and divide it by 4, it would be 1/8. That's right. So negative 1/8. And then if I were to divide by 4 again, it would be negative 1 over 32. And then negative 1 over something that's so huge that it doesn't matter. It's almost close to 0. So let's graph this parent graph. The first coordinate is 0, negative half. 0, negative half is right there. The next coordinate is 1, negative 2. 1, negative 2 is right there. The next coordinate is 2, negative 8, which is down here, almost off the graph. And obviously, I'm not going to graph 3, negative 32. That's way off the graph, so I'm not even going to bother with it. But going in the opposite direction, negative 1, negative 1 over 8. So negative 1 on the x, negative 1 over 8, that's almost nothing. We know that it infinitely approaches the x-axis. So we could actually draw the asymptote, like if it's the asymptote portion of it, that is like if it's touching the actual x-axis, but we know it never actually touches, just infinitely approaches. Now this is the parent graph. What do I need to do with all these coordinates? I need to move them where? Up 6. So I'm going to start with this tail end of it that looks like it's on the x-axis, and I'm going to move that up 6. And I'm going to do it in blue. So 1, 2, 3, 4, 5, 6, it's right here. And I'm actually going to move all of these coordinates up 6 units. So this halfway point, I'm going to move it up 1, 2, 3, 4, 5, 6 to that halfway point. And then I'm going to move the next one up 6 units, and that'll be right there. Then the other one, move it up 6 units. 1, 2, 3, 4, 5, 6, it'll be right there. And we have our blue exponential growth function. What is the asymptote of this blue exponential growth function? That's right. Y equals 6. That's the asymptote. Okay. What is the domain? What is the domain of the blue function? Don't forget x equals all real numbers. And what is the range of the blue function? Y is what? Is y above or below a certain value? Below. And what below? Where is it at? Below what value? See this one right here? It's below that value. So y is below 6. How do I write that? Y is less than 6. And we could also state the y-intercept, which is a coordinate 0 for x, and we got to figure out the y. Now, this was the y-intercept of the parent graph, 0, negative half. If you want, you could just add 6 to that y value of negative half, and you'd get 5.5. Okay, and if you actually saw that on the graph, 0, 0, and then 5.5, 1, 2, 3, 4, 5, and then halfway up. That's why it's that dot right there. The y-intercept is 0, 5.5. For the last one, finally. We do that one for homework. This is the final question on our homework. Let's start by doing an XY table. Let's plug in some consecutive integer inputs from -3 to +3. And then let's actually plug in the easiest one, which would be 0. Plug in 0 right there. 2 to the 0 is 1. So we really have 3 times 1. Now remember, this -9, we're going to ignore it. So what we should do is just box in this, ignore the k value of -9. And once again, when you plug in 0, the easiest one to plug in, that's 1, and 1 times 3 is 3. So for the input 0, the output's 3. Now I could go ahead and plug in a 1 right there. 2 to the 1 is 2 times 3 is 6. But instead of doing that math, I could simply say the growth factor is 2, which means that 3, from 3 to the next one, all I need to do is make it grow by 2. So if I multiply by 2, 3 times 2 gives me 6. And then 6 times 2 gives me 12. And then 12 times 2 gives me 24. Now, of course, the only coordinates we're actually going to be using are 0, 3, and 1 and 6. I mean, 2 and 12, that's all right, but it's going to be off the graph. Let's graph 0, 3. 0, 1, 2, 3 is right here. And let's graph 1, 6. 1, 1, 2, 3, 4, 5, 6. It's right there. And 2, 12, it's going to be 2 units off of the graph. So let's look at the negative. Let's plug in -1. Actually, let's not plug in. We're using the growth factor of 2. So 3 times 2 is 6. 6 times 2 is 12. Backwards, it would be 12 divided by 2 is 6. Divided by 2 is 3. Divided by 2 would be 1.5. So we could just put a 1.5 right there. And then 1.5 divided by 2, $1.50 divided by 2 is 75 cents. So 0.75. And so on and so on. We know it gets closer and closer to 0. Now, of course, you could use a calculator. So if you wanted to do 0.75 divided by 2, you get 0.375, 0.375. But we already know it's going to infinitely approach 0 on this parent graph. So let's start graphing some of these coordinates. We already did 0, 3, 1, 6, and 2, 12. Let me do -1 and 1.5. So here's the origin. If I go -1 and then 1.5, it'd be right there between 1 and 2. Then I go to the next one, -2 and 0.75, -2 and 0.75, and then -3 and 0.3, which is less than half. So we already get the idea. It keeps getting closer and closer and closer to the 0 value, and we're going to draw it like if it's actually touching the x-axis, even though we know it never actually touches, it just infinitely approaches. Now this is our parent graph, so I'm not even going to draw the whole thing. I'm not going to connect the dots. Actually, I want to have to put 2 x's on this, so we know that this is not the actual graph, including the -9. So what we're going to do is take this parent graph, and because the k value is -9, I'm going to shift it 9 units down. So right here, where it infinitely approached the y value of 0, now it's going to infinitely approach the y value of -9. So your asymptote, as it says on the notes, your asymptote will be y equals your k value, and your k value right here you could clearly see is -9. So y equals -9, that's your asymptote. So your graph, once you shift it 9 units down, it's going to infinitely approach that asymptote, the y value of -9. So let me actually shift every single one of these points. This one that's 2 units up, I'm going to shift it 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there. And then the next one, I'm going to take this point right here, shift it 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put a dot right there. Moving on to the next one. This one, move it down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there.